another reason this doesn't work is that there's an attack that the audit can't detect. So suppose I tamper with the value of T by just changing it in yellow storage. I don't even worry about trying to tamper with the log. I just tamper the yellow storage. And then later, before the auditor comes, I untamper. I change the value back to what it should have been. Now, why might I want to do this? This is something a sysadmin might think of. So I tamper with T so that everyone who's running in here will read that tampered value. So maybe T is my salary, and maybe T3, they're going to compute the 4% raises for everyone in the company. So I'm going to double my salary, and then my raise will be computed on my doubled salary, which is great. I'll get a huge raise. And then I quickly change that old record about my old salary back to the correct value before the auditor comes. Normally we don't worry about this kind of thing in the database world. We just sort of trust that what we read is correct, but in some situations maybe you really care that what you read is correct and you want to make sure these tamper-untamper attacks can't happen. Well, there are two ways you could do this. First, that you could guard against this attack, rather. First is you could make audits so fast that you could run them randomly, maybe several times a day, make them really fast. And then the chance that any transactions ran and saw tampered data would get quite small. That's one thing you could do. The other thing you could do is record on purple storage what the transactions read, and then have the auditor check, did they read what they should have read? So that latter approach, when a transaction reads a page, like T1 reads a page that has my salary on it, I can detect the T1 read tampered data if I hash the tuples on P1, add them up, and put that hash value out on purple storage on the transaction log. So normally you don't do that. Normally in the transaction log you don't talk about the values that you read. And then at audit time, the auditor's job is to figure out, okay, I'm scanning the log, I see that transaction 1 read page number 1, and if the hash of the values of the tuples was a certain hash, I need to recreate what should have been on that page at that time and hash those values. And it's kind of tricky because pages split. As the database gets full, pages get full, pages split. In theory, pages can merge. It gets a little tricky, but you just have to write the logic for the code right. It's not that hard, and you can do this. The question is, how much does it slow things down? And I'll talk about that later. Yeah, it's tricky. There's a lot of reasons that it's tricky, but you can definitely do it. Okay. All right. And there are ways that you can speed up what the auditor does for this too, but I'm going to skip over them. And then the last thing is crashes, because when the system is down, an adversary can append anything they want to the end of the log, and there's sort of some philosophical issues in there, plus some practical issues. And I'll just speed to the bottom line, which is that under certain assumptions, we can prove that we can detect these types of attacks as long as we, twice every regret interval, again every 5 minutes or so, we get 5 minutes to get data settled out on disk before we guarantee against tampering. Twice during every regret interval, we close the current log file and start a new one. So database management systems, they all have that ability to close a file and start a new one. They normally don't open and close files all the time. They normally let them get quite big. But we're going to do it twice every regret interval, so maybe every 2.5 minutes or so. Okay, there's another problem with this, but this problem is shared in part by temporal databases, and the problem, transaction time databases, the pages get full of old versions that people don't want to look at most of the time. And that means that when you bring a page into memory, most of the data on it, people don't want to look at. And it makes the whole system run slower because you're bringing in unwanted data. So the transaction time people, Dave LeMay and Betty Salzberg, they worked hard on this problem. They came up with solutions that run super fast. And we piggybacked on what they had done, plus added some new things that we needed. So they have a way to migrate tuples off a page and put them elsewhere. We put them on our purple storage, where we know they're going to be safe for the next 7 years. And we can also migrate parts of a B tree off to purple storage. And that'll make things run faster, and once it's on purple storage, you don't have to audit it every time you do an audit for the next 7 years. You only have to audit it once to make sure it really got to the purple storage, and then you don't have to even include it in the audit, which is really good if you think about 7 years of transactions. That's a lot of information. Okay, so I'll talk about our implementation and how much these added protections cost. Great. We use Berkeley DB, which is not a real DBMS. It's this little bitty embedded DBMS that the source code used to be freely available for. Maybe it still is, but they were bought by Oracle. And our goal, we implemented it 3 different ways with different goals. The first implementation, which is what I'll talk about mostly, was to avoid changing anything in Berkeley DB. So we didn't have a sense going into this how deeply into the innards of the system we'd have to reach. And with a real DBMS, you don't want to mess around with that code, which is very complex and carefully tuned. So it turns out you can implement this outside the DBMS, which is kind of amazing. So that's our first version. The second version, we thought of a way to make audits, to make the whole thing much, much faster. And I'll just speak briefly about that. And then the last version, we put the code inside the DBMS, but that one, the bottom line, I don't have the bottom line on that yet. And we ran it on a slightly old transaction processing benchmark, TPC-C. Okay. And we got the following results. So we ran it for, on just an ordinary slow machine in my lab, we ran it for 100,000 transactions, and it took this amount of time. And then the normal TPC-C is this curve right here, so that's how long it takes. And then if we add protection against tampering with the written data, that adds 10% to the runtime of transactions. And then in addition, we add the assurance that if someone reads tampered data, will be able to detect it later. That adds another 10%. Okay. All right, so that's the first implementation of the system, and the audit time was 5 minutes for this curve and 6.5 for that curve. So at first we thought this is pretty good, considering it's all implemented outside the DBMS. It's our first implementation, and audit times are way down near the bottom of the graph. And then I added this up over a year and found that it came to 2 weeks of time, 24/7. Then I didn't feel so good about it, and I started to think, how can we make audits much faster? But people argue with me about this. They say, well, you know, at the end of the fiscal year, you just rent some time on a cloud, and 24/7 for 2 weeks, you run this audit. Maybe that's okay, maybe it's not. I don't, unless I have an internal cloud, I don't feel comfortable putting all these logs up on the cloud. It makes me a little bit nervous. But maybe sometimes it is the right thing to do. But on the other hand, if I can make audits really, really fast, then I don't have to wait a year to find out if somebody's been tampering with the data. I could just run them anytime. So I prefer a solution based on making audits really fast. And the approach we came up with was, we found that for a regret interval of, I think, even 2 minutes or 30 seconds, so a short regret interval, there's free time. It doesn't take all that long for the log entries there's enough time to do this pre-audit. Probably the log blocks are still visible in memory, so you're hashing stuff you can see in memory, and you can do it really quickly. So it's amortizing the audit time over the whole period rather than just bundling it all together at the end of the year. We can't do that for this read curve if you care about reads, because there are ways to attack it in the case of reads. We can do it for writes. And then audit, at the end of a year, it's down to like 1 minute for a whole year. And that's really good. Okay. That's really good. So I prefer the version where you pre-audit continuously. Then the auditor just has to check, make sure the pre-audit stuff hasn't been tampered with and really was done in a timely manner, and just scan that really quickly, and that makes the audit very fast. And I prefer that because, again, society pays all the costs of these extra protections. I think performance is really important. Some people said, well, why are you worried? You know, 10% performance overhead, that's nothing. That's nothing. Well, maybe they're right, but I don't feel like it's nothing, because if you add it up over all the databases in all the public companies in the U.S., that's a lot of 10%. So I feel that getting the cost way down is really important. And then, of course, no customer right now, no company would buy this because the regulators don't require it. I got to wait for the next big scandal when data wasn't trustworthy and they tightened the interpretation of Sarbanes-Oxley. The actual law itself is so vague that they never need to change the law. They just need to change the interpretation. And then I feel good knowing that we figured out how to do this and how to do it fast. And of course, there'll be additional things to worry about with a real DBMS, a very complex artifact, but the basics, I think, are in place and pretty solid. So someday there'll be a scandal and people will probably pick up something like this and require it. So in this talk, I skipped over a lot of details, like how do we shred stuff. There are these legal subpoenas that make things really complicated, but kind of interesting, and so on. And my conclusion is simply that it is possible to make relational databases tamper evident at low cost. I think less than 1% overhead on running transactions, and then you can do periodic audits very quickly anytime you want. And the approach leverages, of course, the special word storage that the storage industry came up with, and if you want to, you can implement it. For sure, you don't have to make big changes in the DBMS to make it work. That's it. So we've had questions throughout. Any other questions?
Thank you very much, first of all. Any further questions? Comments or?
I'm sure there are other